So the point of this question is to change cot x and tan x into cosec x and sec x. The way these questions are usually sort of written out is we treat this as we have the left hand side and the right hand side. And so rather than having to refer to this bit all the time, we just say we're working on the left hand side. Now, what their solution here does basically uses the trigonometric identities. Now, we know that cot x is equal to 1 over tan x, and so we could say that this question is actually saying, okay, 1 over tan x plus tan x, but that's not really very useful to us. If we wanted to actually make this in, like, give a common denominator, then what we would need to do is do tan x over tan x, and then we have a tan squared x, and that's not necessarily the easiest thing to work with. So what we're actually doing is we're using the fact that tan x is equal to sine divided by cosine, and so that means that cot, because it's 1 over, is just the reciprocal, so that's cosine x over sine x. So now what we've got is cos x over sine x plus sine x over cosine x, and we need to have a common denominator, so what we're going to do is we're going to cross multiply, so get the common denominator from the bottom, multiply those two, multiply those two. So what we're left with is cos times cos on the top, so cos squared x, and then sine times sine plus sine squared x all over cosine x sine x, all the other way around. Okay, now from our Pythagorean identities, we know that cos squared plus sine squared is equal to 1. So we have 1 over, let's do the other way around, sine x cosine x. And then we know, because in the same way that what you can do is have, let's say 1/8 is the same as a quarter times by half. What we're going to do is we're actually going to split this into two separate fractions. So we can say, okay, that's 1 over sine x times by 1 over cosine x. And then we know that 1 over sine x is cosec, and we know that 1 over cos is sec x. And that now equals the right hand side of the original expression, this bit over here. Now, on the next question, we've got, let's see, so 1 minus cosine x over sine squared x. Okay, so we'll work on the left hand side. Working on the left hand side, we are going to do 1 minus cosine x over sine squared x. Now, the Pythagorean identity says that sine squared x plus cosine squared x is equal to 1. So what we can do is we can rearrange that. We can have sine squared x is equal to 1 minus cosine squared x, which looks quite similar to what we've got on the top of the fraction here. So that's why we're going to change that. So we've got 1 minus cosine x all over 1 minus cosine squared x. Now, at the moment we can't cancel anything, that doesn't look very useful, but this is a difference of 2 squares. This is 1 squared, take away cosine squared. And because it's a difference of 2 squares, what we can say is, okay, let's have 1 minus cosine x all over 1 plus cosine x, 1 minus cosine x. Now, at this point, because this whole bit is multiplied by this, what I can do is I can cancel all of that fraction out, because I can cancel all of that one out. I wouldn't be able to cross out the ones individually, I wouldn't be able to do these cosines individually, but because I'm actually going with the whole expression term, if you like, then I can actually cancel both of them out. So what I'm left with is 1 over 1 plus cosine x, which is equal to the right hand side.